Hey, what's up, guys? Kind of Conservative Engineer, aka PE Exam Poppy. Just kidding, nobody calls me that. Let us do another bending stress problem. We're going to use a different equation this time. There is two bending stress equations that you can use for your PE AM civil exam. So in this case, I'm going to make this problem a little different. Say NCES just decides to give you a cross section of the beam, right? It's an I-beam. And let's just say that this beam is a W16 by 10, about by 100. All right, and they say, okay, what is the maximum bending stress? So, and they give you the max moment, right? So let's just say the max moment is, I don't know, 3,000 kip feet. And that's it. This is a very, very easy problem. So normally what there's two bending stress equations. One is the one that we've been using, right, which is the stress equals mc over I. There's another one, which is actually the bending stress is just going to be the moment divided by the section modulus. All right, if you take in wood design or do any wood design, you'll see that this equation pops up a lot. So you pretty much, so let's use the second equation. So you got a W16 by 100, maximum moment is 3,000 kip feet. All you gotta do is just find the section modulus. This is very, very easy. If they give you the beam, exactly what it is, all you have to do is go to your steel manual, your AISC steel manual, table 1-1. I actually have it here. So remember, it's a W16 by 100. I have it right over here. All right, so this is when you open up your steel manual, right at the first part of the dimensions part, you're gonna get a bunch of these tables with, again, different beams and different dimensions. So all you have to do is go over here. So this is your W16 by 100, right? And then you just have to follow the line. So where is your section modulus? It's going to be right over here. Let's do that. So your section modulus is going to be right here, actually, okay? Now, here's the thing. So people will be like, all right, PE exam Poppy, I see a section modulus for the x-axis and a section modulus for the y-axis. Which one do I use? Well, in this case, this is an example of, it's going to be bending about the strong axis, so you're going to use the section modulus right here for the x-axis. And you know what? You should know what the strong axis and weak axis bending is, but we'll just go over it very, very quickly and very generally. Okay, so if you have, let's go brush. Alright, so say you have a beam here, right? So if the load is right here, this is strong axis bending, okay? It's going to be bending about the x-axis. It's going to bend like this, okay? And if you have that same scenario, but the beam is coming, but the load is coming like this, perpendicular to the web, then this is going to be y-axis bending. It's going to be bending like this, and that's called the weak axis. What is weak axis, strong axis? Let's go right here. So it's like which way. So all right, think of it this way, right? This load, in order to destroy the beam, it has to go through the top flange, it has to go through the web and the bottom flange. That is a lot of things this load has to go to. So in this case, this beam is pretty strong, so we call that the strong axis. And in this case, the beam just has to go through this, this thin little web piece right here. This load will absolutely destroy this beam. And this is called the weak axis, because if the load hits like this, then the beam is gone. It's done. And that is your weak axis. Again, please review this topic. But for rule of thumb, for the AM part, it's always going to be, or for the most part, going to be strong axis bending. So we're going to use SXX. All right, instead of SY, we're going to use SX. So let us go back to our steel manual. All right, so right here, remember we are so W16 by 100, and where is, right, so section modulus is going to be this right here, this number, which is 100. Let me zoom in, not the best picture, but right here. Right, so this is going to be this is the section modulus number that you're going to be using. Okay, strong axis bending, the strong axis, so this is 175 inches cubed, and that's it. You're pretty much done with your problem, right? That's it. All you have to do now is just use this equation. You have the max moment, and now you have the section modulus, which is 175, right? Let's just double check. Yep, 175. So how about we just write this out? So now your section modulus is going to be 175 inches cubed, and guess what? That's it. You're pretty much done. So let's do it. So force of bending, your bending stress is m over s. So your moment is 3,000 kip feet, but remember the section modulus is in inches, so we want kip inches, right? So we're going to multiply that by 12, and we're going to divide this by 175. So what do we get? Let me use my handy dandy calculator. 3,000 times 12 divided by 175. And your answer is 205.71, and that is going to be in KSI, kips per inch squared. Right, so that is your answer. Now, listen, your answer choices might be in PSI, and all you have to do is multiply this answer by 1,000, because if you want to go from kips to pounds, you just multiply by 1,000. But yeah, that's it. So real quick, they gave you the beam, which is W16 by 100. They gave you the max moment, and all you had to do was just find the section modulus from table 1.1 of the steel manual, and it's just a simple plug and chug, and there you go. Force of bending, the bending stress is moment over section modulus, and you get 205.71. That is it. Simple problem, should not take you more than 1 minute to do. And yeah, that's it, guys. Thank you so much for watching this video. I'll see you guys next time. You guys have a nice day.